Evaluate the limit as t go to 0 of e to the t minus 1 minus t over t squared. First, we attempt to use direct substitution because both the numerator and the denominator are differentiable and continuous function. In the numerator, if we plug in t equals 0, we have e to the 0 minus 1 minus 0, which is 1 minus 1 minus 0, or 0. In the denominator, it is t squared, but if t is 0, it is 0 squared, which is 0. This is the type 0 over 0. We can apply the L'Hopital rule. Using the L'Hopital rule, taking the limits at t go to 0, we differentiate the numerator and the denominator separately. In the numerator, the derivative of e to the t is e to the t. The derivative of 1 is 0, and the derivative of t is 1. In the denominator, the derivative of t squared is 2t. Simplifying this, we have the limits at t go to 0 of e to the t minus 1 over 2t. The answer to this limit is the same as the answer to the given limit. We treat this limit as a new limit problem. Since the numerator is continuous and the denominator is also continuous, we will attempt to plug in t equals to 0 to check out what the numerator and the denominators are. The numerator is now e to the 0 minus 1, which is 1 minus 1, or 0. And the denominator is 2 times 0, which is 0. This is still in the indeterminate form, so we can use the L'Hopital rules again. Using the L'Hopital rule, again, this is a new problem. So we would differentiate the numerator and the denominator separately. In the numerator, the derivative of e to the t is e to the t minus the derivative of 1 is 0, and in the denominator it is 2. The derivative of 2t is 2. We then simplify this as always. The limits at t go to 0, e to the t over 2. And the answer to this limit is the answer to the given limit, but we treat this limit as a new problem. If this is a new problem and we want to find the limit of this expression, we simply plug in t equals 0 to get e to the 0 over 2, which is 1/2. This 1/2 is the answer for the given limit problem. Evaluate the limit at x go to infinity of 5x plus e to the negative x over 7x. The numerator is a continuous function, and the denominator is also a continuous function. Although we cannot plug in the number, we can take the limits of the numerator and the denominator separately. As x go to infinity, 5x plus e to the negative x, or 5x plus 1 over e to the x, would go to infinity, because a large number plus 0 is a large number. As x go to infinity, in the denominator 7x would go to infinity. This is a type infinity over infinity indeterminate, so we can use the L'Hopital rule. Using the L'Hopital rule, we differentiate the numerator and the denominator separately. The derivative of 5x is 5. The derivative of e to the negative x is e to the negative x times negative 1. In the denominator, the derivative of 7x is 7. And we obtain a new limit problem. This is 5 minus e to the negative x over 7 at x go to infinity. To find the limit, we would need to rewrite the expression without negative power. This is 5 minus 1 over e to the x over 7. As x go to infinity, e to the x go to infinity, so 1 over e to the x would go to 0. We see that this term in the numerator go to 0. And so the answer is 5 minus 0 over 7, or simply 5 over 7.